So in this video, we are going to look at one of the concepts of calculus called the average rate of change. And it's something you've probably looked at previous math classes in pre-calculus and algebra. So the average rate of change is just the change over an interval. So it's really the slope when we're talking about graphically, and in a curve, we say it's the slope of the secant line. So to find the average rate of change, we use the slope formula. We write it this way, where instead of writing y2 minus y1, we write f of b minus f of a, and then we divide that by the quantity a minus b. Or sorry, b minus a. And so this is my slope formula. So if we look at it graphically, we have a curve. We're looking over an interval that starts at a and ends at b, and we're finding the average rate of change, which is the slope of that line, which again is called the secant line. So an example is like the average speed over 5 minutes. We will be doing more applications to business, so finding the average revenue or the average profit or the average cost. So we want to find the average rate of change of f of x over the given interval. So in this case, f of x is x squared plus 2x, and we want to look over the interval 3, 4. So these always represent the x values. They might also write it as like 3 to 4 or use inequality notation like 3 is less than or equal to x, which is less than or equal to 4. Any of those notations are fine. But when we're finding the average rate of change, we're always using this slope formula of f of b minus f of a all over b minus a. So in this case, a is 3 and b is 4. So we're finding f of 4 minus f of 3 all over 4 minus 3. So I'm going to calculate these on the side. So f of 3 is putting 3 in for x. So it's 3 squared plus 2 times 3. So 3 squared gives me 9, and then 2 times 3 gives me 6. 9 plus 6 is 15. And then I did f of 4. So for f of 4, we plug in 4 for all of the x's. So I would do 4 squared plus 2 times 4, which is 16 plus 8, which is 24. So I'm going to plug those in. So f of 4 we found was 24. F of 3 we found to be 15. And then we have 4 minus 3. Okay, so 24 minus 15 is 9 over 1, which is equal to 9. And so this is the average rate of change over an interval. So let's look at one application problem. So if we're given the revenue equation R of x equals 3x minus 0.01x squared, what is the average rate of change in revenue when production changes from 200 units to 500 units? So in this case, x is the number of units. And so that's what we're looking at, the average rate of change when the number of units changes. And my revenue, R of x, is going to be in dollars. It's the price. So when we do this, we use the same formula, but instead of saying F, we do R. So we're going to say like R of B minus R of A all over B minus A. We just use whatever function notation they give me. So in this case, it would be R of 500 minus R of 200 all over 500 minus 200, because these are my x values. So when we find R of 200, again, we plug it into our calculator. So we go 3 times 200 minus 0.01 times 200 squared. And you can also put it in your calculator. Sometimes it's easiest to put it in the y equals and calculate it quickly that way. You just need to be careful when you're typing it in. So I could go to y equals and then y1 and put in this function of 3x minus the 0.01 squared. So in my calculator, I would put 3x and then always use this as my X minus 0.01 X squared. Okay. And so you can do that, and then you can go to second table. And if you hit, you first have to change your operand. Second table set. So if you hit second and then window, that's for table set. And if you go to independent, you can change it to ask. And then if you go to second graph, which gives you the table, you can type in whatever X value you want, and it will give you the Y value. So I could type in 200 and hit enter, and it would give me the Y value. And then I could type in 500 and hit enter, and it would give me the Y value. So you can do it that way, or you can just type this whole thing into your calculator, whichever you're more comfortable with. 3 times 200 minus that 0.01 200 squared. You should get the same answer. So we get 200 for that. And then we'll find R of 500. So again, in our menu, we could do it, or in our table, we could do it, or we could do it here. And so that gives me negative 1,000. And so then I do negative 1,000 minus 200 over 500 minus 200. So negative 1,000 minus 200 is negative 1,200. 500 minus 200 is 300. And then if we divide negative 1,200 by 300, we're going to get negative 4. And if we do units, it's always the units for the Y over the units for the X. So in this case, the units would be the revenues in money, in dollars, so dollars per unit. And so what it means is over this interval, our revenue is decreasing by $4 per unit. So we're losing $4 per unit over this interval. So that's the average rate of change. And there's a lot of practice problems in the class exercises that I recommend you doing.